right, everyone's back. Great. So my name is John Anderson. I'm with NetScout. I'm the product manager for Wi-Fi troubleshooting tools. And I'd like to talk a little bit today about some of the considerations that are put into designing troubleshooting tools and solutions. Obviously we get a lot of great input from all of you and our customer base on new tests and measurements to be included in these tools, new data to be displayed. But we also put a lot of consideration into product attributes. How do we make the products, the tools, and the whole solution faster, more efficient? And so I guess one of the points behind presenting this is I'd like to solicit ongoing input from you. You all have been very generous with input on data and measurements, but also solicit input going forward on things that you think would help make the whole process of fixing Wi-Fi problems and troubleshooting and that more efficient, faster, simpler, because that actually goes a long ways. So it's one thing to try to come up with tools and methods to solve all the problems, but if we can come up with ways of solving most of the problems much faster, all gives you more time to spend weekends at home and with your families, and everybody's happier. So that's why we're going to present this as solving problems in record time, basically much faster. I'll go through some of the design considerations that we take into account when we're designing tools and solutions, why we do some of the things we do, why we don't do other things. And then, show you a few examples of how some very common problems can be solved using these, these new generation of tools. So let's first just take a look at the basic troubleshooting process. So I spent some time online searching for troubleshooting processes that are published that are at this level of detail, and unfortunately there were hundreds of them. Even on Cisco certification site I found 2 or 3 different ones. So basically I try to boil down into a very generalized process. Yes, we first validate the problem, because customers complain. It's not always a valid complaint. They may just be in a bad mood. But once we can validate there is a problem, then we have to isolate that fault. Is it wired? Is it wireless? Is it a specific service, specific area? And then we diagnose what the root cause is. Based on that, we identify and we implement a corrective action, and then we have to validate that we actually solved the problem. So how does this work in real life? Well, the problem is reported as a Wi-Fi problem. It always is. The person taking the call asks for a few basic questions, but a vast majority of the time, the problem doesn't get resolved this way now, does it? So it gets escalated to a technician. The tech consults their wireless LAN management system. And there's some really good information there, and oftentimes a problem can be solved using the wireless LAN management system. But other times, Wi-Fi issues can be location dependent or not related to the Wi-Fi network or the RF at all. So the APs might not see the issue or the cause. So the tech goes to the location of the problem or calls and sends somebody there. And then they solve the problem if they can, or if they cannot. Then they escalate it to a senior tech or an engineer, who then goes to the side of the problem, and, well, it kind of ran off area I could put on one slide. So can this whole process actually be made simpler and more efficient? I mean, one of the objectives here is, can this frontline technician actually solve more problems, or at least isolate the cause to make the escalation go by faster? And typically our troubleshooting tools out there in the industry, they put a lot of focus on new tests and measurements and new data to display. And that gives us a lot of great measurements, a lot of great in-depth analysis that we can do, and a lot of overlap as well. I'm sure we all have multiple tools in our kit that all provide the same basic set of tests and measurements. But the attributes, the use case of these tools can sometimes make it a bit time-consuming to use or difficult. So we're looking at ways to make this whole process simple. Operational expediencies. Can we make the whole workflow of testing and troubleshooting and validating Wi-Fi networks faster, more efficient? What it really means, what it really comes down to is providing faster time to get to your results providing a more integrated and automated workflow, providing a coordinated workflow for escalations and validations. Most of the time these days, from what we've observed, is maintaining and remediating Wi-Fi networks is often a team effort. There's multiple people involved. Oftentimes there's a senior engineer back at corporate headquarters, and they're sending a technician or somebody else on site to do a first level of troubleshooting. So how can this workflow be better coordinated to expedite this process? Take it from days to hours to even just minutes. And also reduce or even eliminate the learning curve. And yes, this is an operational expediency, because when it comes to troubleshooting, most of the time we're learning how to use the tools while we're on site, while we're doing it. Other tools like planning and surveying and validation tools we have go and take classes on, but when it comes to troubleshooting, we're on site. We oftentimes will use a tool we haven't used before or are new to, and we'll learn it while we're on site. So actually reducing that learning curve becomes a good way of improving this overall workflow. And also, a lot of the input we get from Wi-Fi for professionals, a lot of times they'll send another person on site or have another person on site actually trying to solve most of those frontline problems. And so reducing or eliminating learning curve here really helps a lot. So how do we get to some of these expediencies? Again, it's not so much about adding new data and measurements to the test tools, which we, of course, are continuing to do, but also looking at new ways of using these tools, new ways of troubleshooting networks. And form factor is a big part of it. This is our friend George Stefanik from Free Space Wireless using an AirCheck at a very large industrial complex. Wi-Fi can be very physical work. I mean, how many of you have spent all day walking around a site to validate coverage everywhere? Not 10 or 20,000 square feet, but hundreds of thousands, even millions of square feet. Or being at a stadium or an arena and be having to walk up and down tiers and stairs. It can be very physically demanding. Having a form factor that's easy to carry around and light can help reduce the time it takes. Boot time. So a lot of great tools to run on laptops. And yes, I know new laptops. I know Windows 10, for example, on a solid-state drive can now boot up, and if it's brand new, can boot up in maybe 15 seconds. But then you have to log in. You have to wait for all your background processes to complete. You have to start your app, and then you go. And this most often will take more than 30 seconds. So the new line of tools that we're working on, we spent a lot of engineering time, a lot of design into trying to make these things boot up very quickly. Basically, having it boot up in less than 10 seconds is our objective, and we're actually even looking at reducing this further on new tools that we're going. And this does maybe not sound like a whole big difference from a little more than 30 seconds to a little more than less than 10 seconds, but when you're out on site and you don't have this thing on all the time, being able to turn it on real fast and get to results really fast can make a big difference. User interface navigation. So this is a screenshot of the home screen for the AirCheck G2. And oftentimes you need to there's some very common workflows that you do when you're troubleshooting common problems, and you need to get to the right data. So, of course, we can't put in every possible workflow and situation into the UI. So we kind of look at the most common ones where needed to solve most common problems. Make sure the UI navigation is very fast and easy from there. So, for example, you suspect you got too many APs on channel. You want to see if they're all valid. Going from channels to the channel you want. And this is a summary screen of all the channels on the AirCheck G2. To seeing how many APs and the channel utilization, and going right to a list of those. Making sure that's very fast and easy to navigate. Which takes us to the next attribute, and that's the data display. Now that last example was a pretty common workflow, but as you can see, we had to drill down quite a bit. From the home screen, we went 1, 2, 3, 4 levels into the UI. And sometimes you can kind of get lost as far as where you are. So it's a careful balance we try to strike between making the user interface flat, in other words, putting more information on one screen, but also making it readable. Now, after a long day of testing, your eyes and your attentions can become very weary. And so we want to make sure that the UI is at one end fairly flat and easy to navigate, but on the other, it's also very readable. As an example, this is one of my favorite Wi-Fi troubleshooting screens. This is the channel performance screen from the Wi-Fi analyzer. And actually at tonight's session, we'll do a deeper dive into the tools, an AirCheck Wi-Fi analyzer, and we can show some really valuable things you can get off this one screen. But what I love about this screen is there's so much data and information that's available. There's so many problems you can solve here. And it's not all apparent here because it's a very small representation. But you can really drill into all the different types of traffic that's on your channel, what types of frames. You can break it down to management control data, and then from there into all your different types of control data frames, all your different rate speeds. Basically, most anything you need to troubleshoot channel performance issues on one screen, but it's pretty dense. You can compare that to the channel screen on the AirCheck. Much less information, of course. And again, the idea here isn't to solve all of the problems with these tools, but it's to make solving the more common problems faster and easier. And so we really try to we put a lot of consideration. We actually hire usability consultants to help us figure out what's that right balance between having a fairly flat UI that's get to the information you need very quickly versus making these screens readable. And of course, automation is always a big one. What we've learned from users of the AirCheck G2 is the auto test, a lot of times, especially among professionals like in this crowd, it's often used when they send somebody else on site to test something. And they just tell that person that doesn't know much about the tool or Wi-Fi, just go to the home screen and hit the auto test button and report back what it gives you. Or save it and send it to me. So having something that's quick and that easy is also very helpful, especially when you're trying to solve problems with other people on site for you. Next attribute is an integrated and automated workflow. And here, of course, again, the form factor becomes very important. Having something that's fast and easy and comfortable to take around with you on long journeys throughout your site. But also being able to combine multiple tools into one. Now, obviously, as you try to put more test functionality into a tool, it becomes more complicated, becomes costlier, more expensive. So again, we put a lot of design consideration into what's really the most important things. And if you can put the critical tools into one, try to integrate them into one, then it just becomes much faster to get on site. You don't have to take 4 or 5 different devices with you, and again, troubleshoot the more common problems. And then automated upload and storage of results. So if you send somebody else on site, for example, or you're on site, you're doing massive amounts of tests, you don't want to have to sit there and record the results for each one. So having the upload of results be automated really helps in that regard. Next, we have a coordinated workflow. So how many of you out here, just a quick show of hands, how many of you out here pretty much work by yourself? You go out there and you get called on site and you solve the problem by yourself. Okay, how many of you typically work with somebody else? You send somebody else on site first, or you're working on a team, and then you have to, okay, yeah. We got a lot of input on that. The manager or the project lead or a contracted hire, somebody that hires somebody else to go out there and install access points for them. You want to be able to see the results of their tests right away. Or, again, you're on site, you're having to do numerous connectivity tests. You want to be able to make this very fast, very easy. with no additional time added. So this is one of the attributes of a cloud service like Link Life, where you can connect either with an Ethernet test or with a Wi-Fi test, perform your test, automatically upload the results, no additional touch, no additional time needed. So again, it has nothing to do with the actual measurement or the test that's being performed or the data that's being displayed, but it's about the product attribute, the coordinated workflow that will make the whole process faster and easier and less time consuming. And finally, we talk about having no learning curve on the tool. The idea here is as you use the tool, you learn it. And it doesn't take you several days to do that, but you turn on the tool, you go out there, you do some testing with it, and within a few minutes, you pretty much know how to navigate that tool and solve most of the problems with it. This includes putting in our logical embedded links, so links in the tool that make sense. You want to go drill down from one area to another. But at the same time, of course, we need that balance of flatness of user interface, because obviously drilling down into things makes it a little bit less flat, but at the same time, you're presenting less data on one screen. It makes it more readable, easier to find what you're looking for. And of course, automated testing, automated workflows also help to reduce the learning curve for having to troubleshoot and do some of these things. So let's take a look at some of the more common problems and how the AirCheck was designed to solve some of them. If we have some time at the end, we can bring up a live demo and look at a few more and maybe even cover some tips and techniques for using the tool. But what we don't have time to get to during this session, at our evening session this evening, I invite you all to come back. We'll have some food, some drinks, and we'll go a little bit deeper into not only the AirCheck, but also more of our engineering and escalation tools like the Wi-Fi analyzer and how to solve some of the unique features it provides for solving some of these problems. So obviously the auto test. The auto test is a feature that we put in many of our products, One Touch and Link Runner. And the idea here is that you go on site, you power this on, and within 30 seconds, you can see some common key performance indicators, some of the more common problems that may occur in Wi-Fi. Again, you send somebody out on site that doesn't know that much about it, they can use the auto test and get some very fast results into some issues. And part of the auto test can also include connecting to a network and testing connectivity not only on the Wi-Fi part of it, but also on the network and the wired services part of it. But probably one of the more common complaints that technicians and engineers get is that the Wi-Fi is slow. So some of the more common things you want to check for: how many APs are on the channel, airtime utilization of that channel, what access point is the customer actually connecting to, and what rates in that access point are being supported. And are there legacy clients on that, not just that access point or that network, but on that channel? Think about all the neighboring networks around. You may have disabled the lower rates on your APs, but if you're receiving co-channel interference from a neighboring network that did not, they have a lot of legacy devices on that could slow things down for you. So from the home screen, there's one click. Within 10 seconds of powering on, you can get a good view of all the channels in both bands. See if you have any issues with, for example, access points on channels that they should not be on. And of course, you can quickly drill in to see if these are yours or your customers or not. But also, how many access points on each channel? Is the Wi-Fi airtime utilization too high? Or is the non-Wi-Fi airtime utilization too high, which could be a source of interference? So this is all troubleshooting in the channel domain. You can see what we did in the home screen was we put on basically the top 4 domains or perspectives for testing Wi-Fi: networks, your channels, your access points, and your clients. So troubleshooting usually begins with diving into one of these domains. And then, of course, our two one-button tests, auto test and then an Ethernet test. So when you're in the channel domain, which is probably the most common domain for troubleshooting performance issues, you can select the channel that your clients are on that are complaining about slow performance or that you suspect is slow performance. This screen is simply to verify your selection. If you use the AirCheck G2 and you're wondering why this screen is here, the short answer is displaying all the channels on that display, each one being a touch target, makes those touch targets pretty small. And what we found from usability testing was it was very easy to fat finger one. You go to select channel 6 and you hit channel 7 by mistake. And we didn't put the pinch and zoom in there, at least not in this first release. So what we did was put this sort of intermediate screen in there so that if you did fat finger it, you could easily hit one of these two buttons and go to the channel that you really meant to select. And then on the channel's detail screens, you can see an ongoing graph of channel utilization, both for Wi-Fi traffic and non-Wi-Fi traffic. But you can also quickly see how many APs are on that channel, how many clients. And again, this is measuring from the location of where you are. And you want to quickly see then a list of the APs to see if they're all valid or not. You can view all the APs on the channel, see if there's one, see how many are yours, how many are neighboring networks. Is there a rogue in there? Do you need to move one? Do you need to remove one? You can also troubleshoot performance issues in the AP domain. So again, we'll select our network. The top, as soon as we select our network, the top element is the number of APs found on that network, the number of APs broadcasting the SSID. So we select that. We go to list of the APs. And we can select the AP. Typically, by default, it's sorted by signal strength. So more often than not, the one that shows up on top, based on where you currently are, would be the one that a client would connect to at that location. And you can easily check the configuration of that AP. Is it configured with security? But for performance issues, do you have a lot of low rates supported? Are you supporting legacy 802.11 types? Do you have a good enough SNR to give you a decent connection? And one thing that you don't see on here, but you can scroll down and you can expand it into different capabilities set for 11N and 11AC, such as the channel width that it supports, the MCS rates that it supports. Another common issue or common complaint is I can't connect to the wireless. So some of the first things to check is the AP signal and SNR coverage for that network. The configuration. Is the security set correctly on the access points? One of the first things that you can do is at that point, see if you can connect to the network with the AirCheck. If you can connect to the network with the AirCheck, you know the access points are set up correctly. Then you check the client's device to see if that's been configured correctly. I mean, how many of these I can't connect problems typically are pilot error on the user's device, putting in the wrong password or something. Network services and connectivity. What I'm told by a lot of Wi-Fi professionals is most Wi-Fi problems are not Wi-Fi problems. To a user, they are. So a user connects, they try to go out to Facebook site, and they can't get there. It's a Wi-Fi problem. But a lot of times, DHCP, some network service like DHCP or DNS isn't available. Or the WAN is down, the internet down. They can't get out to it. So that's something else to check. When you're connecting with the AirCheck, you can quickly run through those services and see if they're available or not. Congestion and channel overutilization, AP backhaul to the wireless LAN controller on the network. You can always connect to a wireless LAN that's not connected to a network. Getting past there, though, again, the users, they're not going to see this. All they're going to see is I can't connect to the Wi-Fi. So these are very common problems. Probably have all solved them hundreds of times. But being able to get out there on site quickly and within seconds see what these problems are and solve them and get on is something that really makes the whole process faster, more efficient, frees up time. Nobody wants to spend a lot of time trying to fix problems. So troubleshooting this in the network domain. So we, again, within a few seconds of powering on, we can check our network, check for the signal levels, the SNR coverage, make sure there's at least one AP is active. I mean, that may sound kind of silly, but where the user's connecting to, they may, it's not uncommon for an access point to transmit very loudly. The client to easily hear that access point, but then not be able to connect back. So then check for the security type, the 802.11 types that are supported. Make sure the client matches that. And you can drill down to the individual APs if you need to. And then the next thing to run, seeing that the most obvious things are all correct, is try to connect to the Wi-Fi network. So simply hitting this button here, you can connect to the network. If it requires a password, it'll take you to that screen, you enter it, but you just enter it once, and then it's saved as part of your profile, and you can always connect to it after that immediately. And here, you can basically go through each step of the connection process. If it's green, it passes, you're good, you move on. If something here fails, it'll show up as red, and you can immediately drill into that. So one common thing we find is that the connection works, you get an IP address, there's a DHCP server, but the DNS is down. The DNS is not responding. And without that, you're not getting out to the internet, and you have a Wi-Fi problem. If everything works, then the next thing you can do is check the client configuration and make sure they're configured properly. I keep getting disconnected. So here we want to check for AP configurations and client configurations again. See if there's a power mismatch between the AP and the client. Look for interference in the form of non-802.11 channel utilization. Does roaming work? If the client gets disconnected, oftentimes it's the roaming that fails, or there could be unauthorized devices on the network. So again, check, see if the AirCheck G2 can connect from the location of the client. So here we're going to troubleshoot in the network domain. So from the home screen, go into the networks, choose your network, choose connect. Can the AirCheck connect? If so, client misconfiguration is likely. But from here, you can also run a roaming test. So here, once you're connected, the AirCheck will constantly ping a target, such as the gateway. And as you walk around, you can see a line graph that's basically showing the quality of the connection. This is a sort of a mashup of a ping response rate along with what your current connected PHY data rate is. And as these go down, the line graph will go down. Eventually, as you get to a point where your connected rate becomes very low, your ping response rate becomes low, you should be roaming, and you'll see a green vertical line here if you successfully roam. If you don't, if you disconnect, you'll see a red line. There is a connection log in here you can look into. And again, the AirCheck G2 is not going to give you advanced diagnostics or analytics on roaming failures, but it is a first frontline solution to verify whether or not roaming works. Now, here's an example of where it basically disconnected. There's a few things that you can check for. For example, if there's different security types found on APs for the same network, it'll highlight that. So you can go right to the network domain, look at your network, and see if you see this symbol. And that indicates that it found two APs with different security type set. And then troubleshooting in the channel domain. Go to the APs. Go to the AP that shows up on top for your network. This will likely be the AP that a client would connect to at that location. Select the channel that it's on, and then go to the channel utilization screen. Here we see at one point we had an interference source that was generating a great deal of utilization, over 50%. Being on channel 6, this could have been a microwave oven, for example. I'm not exactly sure what we used to generate this. Troubleshooting disconnect problems in the client domain. So here we can very quickly select our network, select the APs, select the AP that our client's probably going to be connecting to. Now, client keeps getting disconnected. That's what the user's saying. I keep getting disconnected. One cause for this is a power mismatch between the client and the AP. So one thing you want to do is go to the location of the client and check the AP signal, make note of it. For example, neg 65 dBm. So the client obviously hears the AP at that point and it's going to issue association requests, may even get connected. But then you go to the AP location and see what the client's signal level is. And can the AP even hear the client at that location on a consistent basis? The clients are connecting to an AP from too far away because they hear the AP, but the AP can't reliably hear that client will get disconnected, or at the very least won't be able to transmit. To the user, it all looks the same. Here's another use for the tool. You're sweeping an area for networks. You're trying to find networks that shouldn't be up and running. This has been used for public events, for sports stadiums, for example. So you can set up a SSID filter and basically put in the SSIDs of your network, of the authorized networks, and choose to exclude them. And then walk around with the AirCheck and look for networks that end up showing up. What this will do then is filter out the networks that you've specified, and we'll try to show show networks that are not authorized in the area. And then you find one, select the APs for it, and then once you select an AP, you can simply hit the locate screen here and go to our real-time signal meter, and it'll try to locate that. Then you walk around and locate that AP. Very similar to the Tentalk we had earlier. So those are some of the common cases. Here's just some list of some tips that have come up on the AirCheck. Testing captive portal networks. Got a lot of requests for this. Does the AirCheck even test captive portal networks? We can go ahead and take a look at this. The answer is, to an extent, it does today. So luckily, fortunately, we have a captive portal network here in the hotel. Now the answer is, we don't yet have a means for providing a browser and login here. It is something we are working on because we've gotten overwhelming demand for it. But in the meantime, most captive portal networks you can still connect to. You just can't enter credentials to get onto the into the internet, but you can still test layer 2 connectivity. And we've even been able to successfully roam on a captive portal network, short of actually being able to log on to it. So here's our captive portal network right here, the Mercure Buddha. It's open, of course. So the padlock here indicates the security type. Red means it's an open network. Yellow means it's WEP. Yeah, you got security, kind of. It's probably not what you want, though. Green is basically WPA2, personal or enterprise or higher. And by the way, if you see a gray icon in there, it means for that network it found 2 or more APs with different security type set. So we choose our network, we choose connect. Because this is the first time that we've connected to this, we'll get the ask for our credentials. And it'll automatically detect the security type used. So if it was WPA2, it'll ask basically, it'll already be set to that, and basically you'll just ask for your password. But here, it's open, so we'll go ahead and hit apply. And it'll run through the connection steps. And yes, we were able to get our connection. And you can drill down on any of these to see exactly what the steps are. So if connection established turned up red, for example, you can drill down to see, did it fail to even make a connection? Did it fail to authenticate? Was it able to exchange packets with the AP? This case, it's getting an IP address, and based on the time it's taken, I'm going to guess it's going to fail this one. This is either a really slow DHCP server or it's been unable to get one here. We should actually see a signal level if we scroll down. Okay, so we failed right here. We were able to connect, but we failed to get an IP address on this one. So here is where you would basically, at that point, go into and look at the DHCP service to see if there's something going on there. So this is something that, now I'm not sure if this particular failure happened because of a true DHCP address. On a captive portal network, we should still get the IP address because you're still going to get redirected to a, DNS will still redirect you to the page in order to log in. And so at that time, you can at least test connectivity up to there. But what we are working on is the ability to actually provide a login so that you can actually go out there. And you'll see one of the last steps of testing is to see if you can actually find a target. And finding that target then would be like a network target. So we'll go back and test to a more secured network. The conference network, we have the password for this, don't we? By the way, this, if in case you've used the AirCheck, you didn't know, this little symbol up here will help you to show the password to make sure you don't typo it. So we immediately get the BSS ID of the AP we're trying to connect to. And this guy is not connecting. So we take a look at the log. And this is interesting. We received an EAP 4-way key start with server. So even though we went in and configured this for WPA2, it looks like it's looking for WPA2 Enterprise. So we choose, that could possibly be a AP misconfigure. I chose a different AP and chose to connect specifically to an access point using our WPA2 personal security setup, and we're able to get a connection. So here we're able to connect, get the IP address, find the gateway DHCP server. We found one DNS, a primary DNS. Unable, though, to ping our network target. So we were able to connect, we were able to get IP address information, but unable to ping google.com. This could be an internet service issue. It could be just getting out of the hotel network. I'm not really sure. But these tests here are basically ping tests. We send 3 pings to the target. And you can configure this with up to 10 different targets. One common use for this is to configure it with the IP address of your wireless LAN controller. Make sure that you can even get to that. The adjacent channel interference test. So this is part of our auto test. And just a quick explanation of what it's doing. So on our auto test, there is a co-channel interference test, and that's pretty simple. It scans all the channels, or all the channels you tell it to scan. Now you can set it up to only scan certain channels. So you can scan anywhere from one channel all the way up to all of them. And then it'll simply count how many APs it finds above signal threshold on each channel and report the ones with the most APs on them. The adjacent channel interference, what this does is on each channel, it will, first of all, it only works in the 2.4 gigahertz band. And it'll go through there, and for any channel on which there is an AP, it will count all the APs on adjacent overlapping channels. So, for example, you have an AP on channel 1, it'll look how many APs are on channels 2, 3, 4, and 5, and report that. Just one tip, though, to keep in mind is it's really, again, it's going to do this test for any channel in which there's an AP. Well, if your network's only on channels 1, 6, and 11, and you got a neighboring network, for example, is on channel 2 or 3 or 4, you don't want counting channels 2, 3, and 4 as part of your results. So what you would want to do here is go into your setup, select only channels 1, 6, and 11 for scanning. Then when you run auto test, what it will do is it will still scan all channels in 2.4 because it's still looking for APs on overlapping channels, but it will only report results for what you specified. So if you go into your channel scan, specify channels 1, 6, and 11 and run auto test, it will only report results on those channels, even though it will scan all channels for results. And that's really easy to do. In fact, do we have a lot of APs on? We really don't. So we can very quickly see here we only have APs on 1, 6, and 11. So our auto test ACI should come up with 0. We'll run it quick and see. I'm sorry? Sorry about that. Thank you. So the auto test basically is going to perform a passive scan of all the channels. You can select certain channels in 5 gig band, for example, and only scan those channels. Again, it's going to scan all the channels in 2.4 because of this adjacent channel interference. Then you can also configure it to test for different networks. Now, I've configured this auto test to test for a network called Auditorium at the place I was before I came to Budapest, so it's not going to find it here. But we can go down here and pull down results for adjacent channel interference and basically You see we got all zeros because we could see from the channel screen we didn't have anything on overlapping channels, which is a good thing here. But of course you're not going to see that in all environments, and especially in dense environments where you have a lot of neighboring networks around you. Resolving hidden networks. So the AirCheck can find hidden networks, and by default it will report them basically as hidden in the BSSID of the AP it found. It can resolve the SSID, and it does this in a couple of different ways. One way is not so fast, the other way is much faster, but the not so fast way it can do this is if there's client traffic, if it detects clients connecting to a hidden network, it can pick up those that traffic and resolve this particular BSSID has a hidden SSID, and this is what that SSID is. And that works. Of course, you have to scan the channels. You have to pick up client traffic as you're scanning. So if you know of a hidden network, you want to pick that up much faster. One thing that the AirCheck G2 does do is it will transmit probe requests, and it will always do generic probe requests. You can turn that off, by the way, if you don't want it transmitting. If you're in an area where you can't transmit, you can turn that off. But by default, it's going to transmit generic probe requests. But if you configure a network in your particular profile you're using, it will transmit probe requests for those specific networks. So if you know of a hidden network that you have in an area, you want to resolve it quickly so you can run a connection test to it, simply configure in your profile, and the AirCheck G2 will transmit the probes for that network and will quickly find it and resolve it. And then it'll show up in the home screen. I'm not sure if we have any hidden networks out there here. We'll take a look and see. Here's one hidden network. In fact, one thing I'm going to do is up here is you have the sort button. So I'm going to, by default, it sorts networks on signal strength, which makes sense. But I'm going to go in here and sort on SSID. And actually, I take that back. I think by default, the network sort is SSID. And if I reverse the sort order with this button here, I can see any hidden networks showing up here on top. Now, I did find this flapjack network here, which is from the access point that I brought here as a hidden network, and was able to resolve that. I was able to resolve that because I configured it into my profile, and so it's sending out probes for it, and was able to see it very quickly. Adding a network to a profile. Now, you saw from the keyboard when I typed in the password, the keyboard can be a little painful to use. Yes, I hear you. And some of these SSIDs can get pretty long, and I hate typing in a 20-character SSID. It's easy. All you have to do is select that network from your network screen and then select to connect to it. You don't even have to actually go in there and connect to it. If you just select connect, it will add that profile or add that network to your profile automatically. Then you don't have to type in those long names. Just got to make sure you do save that profile after you've hidden it. So for example, right now, up here is the profile I have running. It's called default. If I click it, I'll go to profiles page, and I can do all sorts of things with it, but I can take a quick look under settings at what networks I currently have configured. You can see I have quite a few networks already configured in my profile, but I don't have any of the ones here. So if I want to add, for example, WLPC EU4 to my profile, I don't have to type that in. All I have to do is choose connect. I'm not even going to type in the right password. If I just type in anything here, hit done, and then choose apply. I'll try to connect. It's going to fail during the authentication, of course, because I typed in the wrong password, but I can go take a look at my networks page now, and it now has that network added to it. Now, granted, that's probably not a very painful SSID to add in, but for longer ones, that's just a quick and easy way of doing it. Oh, and screen captures, in case you didn't know, very easy to do on the AirCheck. You just basically press and hold the question mark. This is your embedded help, by the way. Anytime you wonder what a certain symbol means, for example, I'm wondering what those padlock symbols mean, you just go to the embedded help. It'll explain it. But we've got a lot of requests that kind of surprised me at first, but people wanted to be able to get screenshots to show, they capture something that looks interesting, want to be able to show a customer. So all you got to do is press and hold the question mark button. And you can get a screenshot here. And then you go into your settings, manage files, and you can basically download You can download all your screen captures as well as your test results directly to a USB drive, or plug it into the AirCheck Manager, which is our companion PC app, and import those in. And by the way, so those of you who have used the AirCheck realize that just like the Link Sprinter, the Link Runner, when you connect to a network, either wireless or Ethernet, it will automatically upload those results to our Link Live Cloud service. How many here have used the Link Live Cloud service before? Okay. So we're... obviously, that was our first go at it with the AirCheck, having the connection test. We're interested in getting other results up there. The AirCheck Manager, which is our companion app, runs on Windows, and yeah, we get requests for Mac version of that, but Android. In a way, I think it would be easier if we just put everything in the cloud, then you can access it from any platform. So one of the feedback I'd be interested in getting from you, especially the AirCheck users, is what are some of the top priorities for results you'd like to see up there in the cloud. We can get to work on those as the first bit. And then filters, of course, signal level and SSID. So by default, it'll show everything, but just like we showed in our network sweeping example, sometimes you only want to look at certain SSIDs. In fact, when we first released this, we had an SSID filter where you'd enter the SSID, it would only show you that. We got feedback saying, well, I want to see all the other SSIDs, not mine, because I want to see what's out there that shouldn't be. So we added the inverse to that, so you could either exclude or include them. There's actually a stadium testing that we got the feedback for on that one. And then, of course, talked about the AirCheck G2 Manager for analyzing results. One thing, the AirCheck G2 Manager, yes, it's a Windows app. It's pretty slick, though, because one of the things you can do is you can save all your sessions on your AirCheck. You can import all of those into the AirCheck Manager app. You can display multiple ones. And the results are displayed in tables, and you can simply copy and paste those tables into a spreadsheet if you want to do further analytics. So you want to look at all the results collected over the past week for specific networks, specific channels. You want to do filtering, you want to do sorting, you want to do analytics on that. You can just basically copy and paste those tables into a spreadsheet and do those type of analytics. And then on the Link Live, one really slick thing about that I really like is the fact that you upload test results from your connection test. You can almost in just within seconds later get an email with those test results. If you reply to that email, you can type in a little comment. This was tested here in the corner office on this day. It was tested when nobody else was here, whatever. And then those notes would get attached to that result in Link Live. So you go back a month later, and you can see the context around that particular test that you did. One final thing here is on profiles. So AirCheck does run on specific profiles. These are useful for setting up different configuration parameters, different thresholds. One common use case for this is you got different tests or different sites to test. The sites may have different networks or maybe have different thresholds. You maybe want to test different thresholds for different services, voice in one area, data in another. So you can save all these different profiles, load them on your tool. Then when you're out, all you got to do is load the profile you want, do all your testing, save those, load the next profile, do your testing, save those. And those thresholds are, again, good for pass-fail testing. So you can quickly check your results and just look through for all the failures and dig deeper into those. And that's one of the useful things for the AirCheck Manager. You can create profiles, all your thresholds, all your settings. You can create them on the tool itself. So you're out in the field, you want to change something, quick and easy to do. But especially if you have a lot of networks and credentials to enter for connectivity tests, it's just easier to do that on a laptop than to use the onboard keyboard of the AirCheck. And then finally, the remote user interface, a little bit of confusion around this. This is not for remotely testing a device that's placed in some other city or some other country. It's really, we designed it for doing web conferences or demos on your laptop, so it's been very useful for doing WebExes, for doing training. You can put the UI, and I'm running it right here. Basically, all you need to do is install a VNC viewer on your laptop. And then you go to, you have to connect the AirCheck with an Ethernet cable, and you have to be on the same local network. That's really the restriction right now, is that you have to be on the same local network in order for this to work. But provided that you are, you simply go to Settings, and down here at the bottom we have Device Settings, and then we have the Remote User Interface. And I click that. When I hit Apply, what it'll do is it'll pop up a screen on the tool that shows me the IP address. I just type that into my my VNC viewer here, and I got my connection. If I do it from here, I don't know if it'll actually come through. Yeah, no, I just broke my connection. That's okay because I can set it up again. So I look at the IP address 1.90. I type it in here, hit connect, and I got my UI. Yes. So what you're saying is we could have come up with a better name for the feature. So that's all we have. Again, I invite you to our session tonight. We'll take a little bit deeper dive either into the AirCheck, also into the Wi-Fi analyzer, even the Spectrum XT, show a few things that you can do on those tools. Oh, yes, and we will be having a raffle for 2 AirCheck G2s.
How about 2 raffles for 1 each?
Okay.
Okay.
We'll do it Keith's way. We'll give away 1 each to 2 different people. But you have to be present to win. No, you don't have to be sober. You just have to be present.
Less sober might help.
Yes.
Right. Thank you very much.